Hello, this is János, and this video is about mass loading for Voigt pipes and transmission lines. And this is a subject that I've noticed. I received a few comments which emphasize the fact that mass loading, the term of mass loading applied here, is really confusing, because there are two things happening, and people use the same name for both of the phenomena. And so that is that some people, when they say mass load the transmission line, mean this: to put stuffing inside the transmission line or the void pipe, and you add a mass of wool or polyfill fiber or something like a cottony fluffy material to basically stuff your speaker. And then what this does is that when you do that, when you put stuffing in a loudspeaker, then it will effectively make your inner cabinet size longer, and that's because the air takes longer time. The air pressure takes longer time to go through a stuffing than through free air. And basically, if you fully stuff your loudspeaker cabinet, it is equivalent to you designing the cabinet 30% larger. So basically, if you have like a transmission line that is unstuffed, then when you fully stuff it, it's like having a 30% longer transmission line. So if that's the case, why don't everyone stuff their pipes full? and then it's like extra 30% bonus, and the reason is that there's no such thing as a free lunch. That stuffing has several effects, and one of the effects is that if I'm not looking at it like from the standpoints of physics and try to explain what is actually happening, what the physics is behind it, just from the standpoint of an observer when I'm listening to it, which is the practical part for you. What happens when you stuff your pipe or when you mass load your transmission line with stuffing material. And then what happens is that the more and more stuffing you add, the more and more imbalances in the base region start to even out. And that's because when you have a pipe, it acts as a comb filter. So especially in the base region, you will have comb filtering appearing. That's the property of every pipe and transmission line. And as you add stuffing to it, you are decreasing. The more stuffing you add, the more you decrease this combing effect. And for that reason, I would say the majority of the transmission lines and pipes I've seen on the internet that people are building and they're giving advice for, they tend to be just massively overstuffed. And another reason for that is that in practicality, when you overstuff your pipe or transmission line, it has a tendency that it will be friendlier with solid state amplifiers. So when you are using your transmission line or pipe with a tube amp versus solid state amp, when you have a tube amp, then a non-stuffed pipe, it will be able to handle a non-stuffed pipe better. You will perceive the sound as having a lot more life to it, a lot more speed, a lot more punch to it. It's kind of like a wild horse, like a Mustang that can, from standing still one moment, the next millisecond it's running full speed. And this effect can also be just over exaggerated, where the sound feels like a Mustang who is just totally out of control. So it's like from 0 to 100 next to 0 seconds, but then it won't stop. It just goes crazy when it should not. And then you start to add a little bit of stuffing. Just put a little stuff down here, and if it's not enough, you add more, and just progressively add a little bit more until you strike the balance. And when you have two BEMs, usually you will need to add less stuffing to strike an optimal balance. For solid state amps, you want to add more stuffing to have like an optimal transmission line, speaker amp match. And of course, there's the psychological effect of stuffing, that when you add more stuffing, almost always you always hear it as a massive improvement in the sound. But try it, stuff it fully, and then you will think that your bass is getting better and better and better, and that impression will be the most prominent for you. But you will not notice, it won't be apparent, that while the bass is getting better, the mid-range is getting worse and worse and worse. And that's because especially male listeners, our preferences are really, our brain is really keen on interpreting the bass, and we won't notice how the mid-range is getting just butchered when you add more stuffing into the speaker. When women also are there, their attention is more on the mid-range, and they will tell you immediately that, oh, the mid-range got killed, or just probably they will say that now it sounds worse than before, and probably they won't be able to give an explanation, but that's behind it. And what you can do is that after you fully stuffed it, listen to the speakers for about a month or so, put on diverse material, listen to your CDs, your stream, API, cassette tape, reel-to-reel, whatever you have, classical music, put on your favorite music, put on your most disliked audiophile samplers or whatnots that you just listen to torture your speakers for no apparent reason. Listen to everything, and then remove the stuffing after that time period and listen to them again, and then you will notice and learn for yourself what is the difference between a fully stuffed and fully non-stuffed speaker, like maximum stuffing versus no stuffing. And when I'm doing my videos, I always call it as stuffing. I never ever refer to this as mass loading, because this is just stuffing, and actually this is not affecting the drivers as seeing a heavier drag on the driver, because what the other meaning for mass loading your transmission line is to make the air column seem for the driver as if it's getting heavier. So basically it's air mass loading. What does this mean? So when I have my Voigt pipe here or my transmission line here fully unstuffed, what's happening? Let's look at the transmission line first. So here we have the driver. When the driver is moving back and forth, I hope you can see this, then it's creating air pressure changes. So it's when it moves forward, and it pushes the air of the room forward, and it pulls the air which is in the pipe, in the column here, in the transmission line, it pulls it behind it. And now the effort for your driver to push the air and to pull the air, it's equal, because in front of the driver has a certain amount of surface, so it's pushing the air in that surface area, and here when you optimally design your transmission line or Voigt pipe, the mouth of the pipe has the same surface area as the driver's surface. So what this means is that when the driver is moving forward, then the same amount of air that's being pulled out from the top of the driver can enter at the bottom of the driver, and they are moving at the same speeds. So same surface area being pulled, same surface area being pushed. So here we have like a free exchange, and that's how a pipe works, that there's a column of air where the sound waves bounce back and forth from the top and bottom of the column, but they can exit at the mouth of the port at the same speed as the fluctuations are at your driver cone. That's how pipes work. And when we mass load, when I in one terminology is when you make the mouth of the pipe smaller. So it means that now if the speed of the air is certain at the top, then at the mouth where the driver is, then at the mouth the speed is a lot faster, a lot higher. So it means that there's a drag and there's a push. So the column is no longer a free column. Let's say like this. So you see, now here we have a column of air, and there the exit of the column is much smaller. So now the air cannot move freely within here. So we have a semi-pressurized column of air inside the pipe, and that's when we are mass loading the pipe. So it feels for the cone as if the air is much heavier now compared to how it was before. So we are making the air heavier. That's how we are mass loading it. And of course the air is not getting heavier, the molecules have the same weight as ever, but we have restricted their ability to enter and exit the cabinet through the mouth of the cabinet, and that's why it feels for the driver that it has to put in more work to move that column of air than before. And it's equivalent to like having a car engine, and now you are increasing the weight that you are dragging with your car. So basically that's what it is. And why is that beneficial? That's beneficial because with this mass loading you will basically kind of like start to pressurize the transmission line at the low frequencies. Especially at the low frequencies, the lower you go, the more they get pressurized, but you also like start restricting the low end of the transmission line as well. So when you have like a fully unloaded transmission line like this, then you hit like the quarter wave frequency, which is kind of like that frequency up to which your cabinet can support I would say full energy output. But then through that quarter wave down to an eighth of the wave, 1/8 wave, its output is dropping, but there's still energy and exiting down to 1/8 of the length of the pipe basically. And when we are mass loading it, then down to that quarter wave part, we are improving how that quarter wave is transmitted to your room, but we are compromising that 1/8 of a range, that octave below it. So that will kind of start to disappear. However, I have to add to it as well that it depends also a lot on how you mass load it and how you design it. because you can make this mass loading so narrow as to have this exit act as a port. So then basically you are putting a port on your transmission line, and that's like the most of the extreme of mass loading your pipe. And then it actually you can calculate using it almost like a bass reflex cabinet, but it still won't behave as a bass reflex cabinet. It's still going to be a pipe, but it will interface with the room a little bit more like a bass reflex cabinet. It becomes like a hybrid bass reflex transmission line. And you want to do this when the unloaded version is unable to load your room at the bass frequencies. So what happens? So when you have your transmission line and you have problem with the bass, you don't have enough bass, or if it's it's really, so the lowest octave is not there, you are, or even like the bottom of the mid bass, like the deep bass, you are having issues, then you want to start to do this acoustic mass loading. And it's not like the cabinet's fault, because in some rooms, when you have this completely unloaded version, it can absolutely beautifully load your room. You will start to have room loading problems when you go to smaller and smaller rooms. When you go to a smaller room, then your pipe won't be able to energize your room at the low frequencies. That's when you have to start mass loading it by making the mouth area smaller and smaller. And the most extreme to it is basically you are making it so small that you have a port here. Now that's it. So, and the other thing is what you are noticing, that if in your room you have very choppy bass, so you don't have problem with the bass output, but what you have is like certain frequencies are really strong and others just non-existent. It's like really unruly. It's then you want to start stuffing your pipe, because that stuffing will equalize that bass region. Now what I recommend is that don't just rely extensively, uniquely on stuffing the pipe. When you see that choppiness, that's also extremely connected with the placement of your speakers. So play around a lot with where exactly your speakers are, often just moving them like 1 inch to each side, or half an inch, or just toe in, just change the toe in by just 2 or 3 degrees. Like really minor changes can massively impact on that combing that you observe. And try to have like optimal speaker placements, and then play around with optimal stuffing. And as I said, both of these, optimal speaker placement, optimal stuffing, and optimal size of the mouth, it depends on how your speaker interacts with the size of your room and with your amplifier and the placement. So all of these are variables that will define what is your optimal solution. So I think that's it what I wanted to say in this video, that when you hear about mass loading transmission lines, in most videos people don't make it clear what they are talking about, and I am guilty. I've been guilty of this in the past as well. However, now I'm making this clarification that whenever I was talking about mass loading your transmission line, I'm exclusively, almost, I think, maybe not, but I think in most cases, or almost every case, I was thinking about basically closing down the transmission line mouth and getting towards like a ported configuration, halfway there or full way there. It depends on each and every single case, and when you take your transmission line from one room to a different room, you have to start this optimization process again. And that's why you cannot just judge a transmission line speaker as is, because they have to be tuned to the room and to the amplifier and fine-tuned speaker placement. And when you do all of that, that's when you can hear what they can really do. And the difference between an untuned transmission line or a Voigt pipe that is not tuned to a room, just you get something, order it on the internet, plug it in your room, the difference between them can be literally night and day. So like if you have like this type of Voigt pipe, the one that I have, my straight Voigt pipe, depending on the room and amp, it can literally sound like a $200 speaker I bought at a garage sale, or like a $50,000 speaker that's like getting you the most incredible sound you ever heard in your life. And it's the very same speaker, and the difference is just setup and what the amplifier is. And that's how a lot of so if you design your speakers properly, if you build them with really good material, and you have good responsive drivers, then that is what you can expect. What makes or breaks it is how you stuff it and how you mass load it, whether it's needed or not. So and this is something that you have to just experiment with, figure it out for yourself. And one thing I would like to cover, one thing in this video, is that I have had many questions asking about how about Voigt pipe with a tiny driver, because the low frequency output really depends on the size of the driver. And what you can notice, that even if you put like a really tiny driver onto a tall pipe, you can get like a bass response that is a lot lower than what the specifications of the driver ask for. So for example, you can put like a tiny 4-inch driver into a Voigt pipe that has like a self-resonant frequency of 70 Hertz, and you can get pretty good bass out of it, down to like 45 Hertz or 40 Hertz. And this doesn't make any sense. It goes like almost like an octave lower than you would expect from this driver. And then this happens when your pipe is not stuffed. And when you actually, you can also add some stuffing to it as well, but then you must not air mass load it. So you must not close down the port, because now if you are closing down the port size, then you are making it harder for the driver to drag that air column, and now that's when that self-resonant frequency of the driver will come to play. And this is when you will find out that the driver is unable to move at those frequencies an air column that has a big drag to it. And that's when you will start losing the bass, and that's when you notice that, okay, I put the port on it and bass effectively, or tiny mouth, and now it's unable. Now it's like down to like 70-80 Hertz maybe, the extension, but not lower. And then when you open it up, now it can because it does not have that drag behind it. So now it just, at those low frequencies, it still can move back and forth, and there's no heavy air mass for it to drag, and that's why its lower extension can be significantly lower than the self-resonance of the driver. Of course, you will be limited to the fact that because of the small cone area, your peak output volume will be limited, But if you have a tiny driver and you want really deep bass out of it, then have this big mouth for the driver, so that it doesn't need to drag that mass loaded air column, that air mass behind it, that is just a free air. Of course, if your room is such that it would need mass loading for the pipe to interact, then with a small driver you won't be able to have deep bass. Then your answer is this mass loading plus bigger driver. So I hope these advices are helpful for transmission line and Voigt pipe users, and have an awesome day. Bye bye.